Hi there. We're looking at properties of real numbers today. I'm Rebecca Weaver, and let's get started. First, we have to figure out what real numbers are. This is a cool little diagram, and it shows how the numbers are related to each other, but we have names for these different, what we call sets of numbers. The counting numbers, the numbers that we naturally start counting with, we use our hands for this. This is where kids first start. We go 1, 2, 3, 4. We call those counting numbers. See, they're in the center of our diagram there under, actually to the center and then the left. Whole numbers. Whole numbers are basically the same as counting numbers, but we included a zero in that. So it starts with 0 and goes 1, 2, 3. So there's a one-to-one association, but we include 0. One-to-one association with our fingers still. Integers. Well, these are really pretty numbers. This allows us to owe money or owe somebody or go backwards or go down or whatever. That's what a negative represents. So the integers are -3, -2, -1, 0, 1, 2, 3, and it goes in both directions from there. The rational numbers, where we start including the fractions. They're a number of the form p over q, where p and q are integers and q is not 0. It's all of the above numbers plus some terminating and repeating decimals. So like 1/2 is a rational number, and it's of course 0.5. If it's a decimal that repeats, like 1/3 is 0.333333333, and it goes on and on and on, that's rational because I can write it as a fraction. The irrational numbers are just numbers that aren't rational. They're numbers that include pi, square roots of prime numbers, non-terminating, non-repeating decimals. I just call them the crazy numbers. And they're a big set of numbers too. Real numbers, they're just all of the above. So let's look at some square roots. Let's work with some square roots. So I'm just going to look at square root of just a regular straightforward perfect square number such as the square root of 9. Square root of 9 equals the square root of 3 times 3. When you're looking at square roots, you say, is there a number there that is it perfect? It has a perfect square. And 9 does have a perfect square. That's 3. So the answer to the square root of 9 is 3. A negative on the outside means negative times the square root of 9. So I would do my square root of 9, which is 3, and then say negative times that, which would be -3. However, if you put a negative inside the square root, that's not a real number because I can't get a -9 from a pair. If it were a -3, say -3 times -3 doesn't equal -9, it equals +9. So that couldn't be. So anytime you see that negative on the inside of a square root, just say, that's not a real number. Eventually, we'll get into something called imaginary numbers, but not in this course. So if you see a negative on the inside of a square root, just say, not a real number. You're just done, basically. So let's look at the distributive property. Just refreshing what the distributive property means. If I have 2 times the quantity x plus y, one of the things that we did a long time ago was we took and we said, if I can get my little pen to work, we said 2 times this x times this y, and we said, okay, so 2 times the x plus 2 times the y. We could have also said that's 2 of these x plus y guys. 2 plus x, 2 times x plus y means x plus y plus x plus y. However way that we cut it, we're still going to get 2 x's added with 2 y's. And that's how it simplifies. They're not like terms, so we can't add them. You can choose to write this whole thing down multiple times, or just say I'm going to multiply here and I'm going to multiply here. In which case you would get 5x times 2x minus, keep that sign now, 5x times 6y. Don't forget that back end, guys. It's an easy mistake to make. I would just get 10x squared minus 30 times xy. Moving along and doing a little one that's a little more complicated, I'm going to do this 6 times 2y, that's going to be 12y, minus 6 times 5, That's minus 30. Now be sure that this minus sign goes to both these two guys because it is minus 3y and minus the minus 2. Notice how I wrote minus 3y and plus 2 because minus a minus 2 is plus 2. That is the most common mistake right there that I see students make. They miss problems because they forget about this minus minus guy. Be very careful on that one. That's why I included it. So when I add these like terms, 12y minus 3y, I get 9y, and minus 30 plus 2 is minus 28. Now I know that this was a refresher, and it was kind of a quick refresher, but hopefully that helps, and I wanted to be sure to include that most common mistake that I see students make. Those negatives tend to throw things like into a whole nother ball of muck. So if you have any questions, you need any help, you be sure and let me know. Just email me, and y'all have a wonderful day. Bye now.